do. All right, ladies and gentlemen, says that we are recording and I'm sharing my screen. So let's have some fun here. So good evening. We're on lesson 3. Should be good stuff. I put out an announcement to check out a discussion to respond to if you would like to talk about cybersecurity or entry into the cybersecurity field. If you answer by Thursday by 11:59, I'll be able to organize some stuff for next week or the week after. Another guest who works in the cybersecurity industry join a Zoom meeting, but that whole thread is to determine when the best time is for that Zoom meeting, and it'll be recorded no matter who joins, and we'll talk about how to enter the cybersecurity community, join the community, look for jobs. We'll take some Q&A. It'll be a good time. Now let's talk about this lesson. So lesson 3, this is putting it all together. Every lesson we're going to keep adding on to logic and ways of how to organize our thoughts and leverage Python to critically think to solve problems. We're going to keep adding on to it every week. Here we have iterators and generators. So iterators are things that repeat or enumerate through, like a while loop or for loop. And then you have a generator, which creates something, right? Topic called range. It's a special function. It is, one may say, it is literally designed to work with for loops. So what is a range? Well, you can see if you get help on range. Gotta spell it right. That's the important thing, right? R-A-N-G-E. And it has 93 line squeeze. We'll double click it. It's a class object, a range object. It has a stop if you just use it with one argument, as a start, stop, and a step if you use all 3. And a step appears to be optional, right? So what does that really mean? Well, let's just say x equals, let's do var1. I like using var1. var1 equals range, and we'll say we're going to have a range of 5. I'm going to hit enter. So when I call on var1, it has range 0 through 5. Okay. So the start is 0, the stop is 5. So what you're going to have is 0, 1, 2, 3, 4. That's 5 objects. 0, 1, 2, 3, 4. 5 objects. Gotcha. Okay, well, what can we do with this? We can do a lot, right? Well, before we get any further, let's do a range. Let's say start at 0, stop at 11, count by 2, and hit enter. Well, there's your range, right? Doesn't really create anything, though, even in the variable. Well, then here comes 4, right? You could say for each object or for each item in range, and we'll do exactly what we just did. Start at 0, stop at 11, counting by 2. We could say print item. Now, this should print each item in the range until it's done. That's exactly what it did. So we said start at 0, stop at 11, count by 2. For 0, print 2. Or for 0, print 0. For 2, print 2. For 4, print 4. For 6, print 6. 8, print 8. 10, print 10. Stop. And we're done. So a range, you could literally use the start and stop for a for loop and end your logic, whatever your script block is in your for loop, right here. Now, I just want to spend a little bit more time on range because you could do some cool stuff with range. Over here, I have, over on the left side, I have range, stop at 5, so 0 through 4. 0 through 4 will be stored in a range. I'm going to print out a range. and then I'm going to turn it to a list. I'm going to use the list function and say list range. That's all I'm going to do. I'm going to hit F5 on the screen. And this line, of course, is this. The next line is where I turn it into a list, and I have each item of my range in a list now. 0, 1, 2, 3, 4. Helpful, not necessary. You could use a list here too. So if you took this list of a range, right? If I did type right now of a_range, man, I'm having a hard time typing range today. You're going to see that it is a range because list only temporarily changed it and displayed the items in the range. Now, if you did var2 equals list of a_range, and then did var2, now it's the list. So now it holds each item that was declared in your range. Now you can do a type on var2, and you'll see that it's a list. And I could do for each item in var2, print the item, right? We'll talk about for loops here in a minute. But now we have each item in the list iterated through a for loop. For each item in my list, print item 0. For 1, print 1. For 2, print 2. For 3, print 3. For 4, print 4. So range allows you to set a start and stop of something. Very helpful. Let's get to some more fun-filled examples here. So we have this one. Let's run this one. So here we're going to have for each item in my range, print I. I already ran through this, but I'm just showing you this in the code. And now it's the same thing, right? We didn't have to change it to a list here. You don't have to. That's the beauty of range. We're saying range stop at 5, so instantly you get your 0 through 4. So for 0, print 0, so on and so forth. Awesome. And now we have this one. Save at 5. And here, just, we store the range of 10, and we have it starting at 0, stopping at 10. That's basically what this just shows you. And I'm going to go ahead and remove this, and remove this, and we'll run the last section together. So ranges, you can start and stop anywhere you want. So here we start at 10 and stop at 16. So you have 10, 11, 12, 13, 14, 15. And this just prints the range, no big deal. And here we say, this is pretty tricky. Start at 10, stop at -10, so -9, and then count by -1. So when you store this range, a range, I print it, it's right here. And when I turn it to a list, what you're going to have is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, all the way to -9, because we told it to stop at -10. So you still have your 20 items because of 0, but that wasn't the goal, right? It was to start at 10, stop at -10, resulting in -9. So you can count backwards. Super handy for doing a chessboard, right? Think of that. There's 8 spaces. Start at 8, stop at 0, count backwards -1. There's your chessboard, right? Perhaps. But range, it generates a sequence of integers. So you can control the integers you want within that range or set of numbers. Extremely handy. Let's take a look at the, and range is designed for loops. So we'll dive right into a for loop, right? And right here, for loop executes a block of code for each element iterated within your list or range, right? So what I like to say is for each item in my items, a repeat that again. For each item in my items. And here's a simple range. For each element in my range of 5, print the element, and with a space instead of a return. So you'll get 0 through 4 all on one line. Let's see, we'll stop. I'll just rip through all these. I'll hit F5 on this. We'll walk through them. So this right here says for each item in my range of 5, print the item with the space. So for 0, print the 0. For 1, all the way to 4. And that matches that script block. And here we say start at 1 and at 6. So print 1, print 2, print 3, print 4, print 5, stop. And that's exactly what we get. Here's a fun countdown, right? For each element in my range, starting at 5, stopping at -1, counting backwards, they're stepping by -1. So print the element 5, 4, 3, 2, 1, 0. That's exactly what you have right here for this. Now, strings are naturally, you can enumerate or iterate through a string naturally. And here we have an S is a string, but combined with other strings, it makes a word. In our case, it's still a string, and it is literally the word string. For each character, and this could be any variable name that matches the variable in PEP 8, right? For each character in my string, print the character. Well, it iterates through each string. For S in string, print S. For T, print T. For R, for I, and G. And when it's done, the script block is over, prints the empty line. That's what we have right here. Now let's take a look at the rest of these, right? So here we have, a tuple. Tuple's different than a range or a list. A list is a combination of an object that holds objects that's iterable, so you could change it. A tuple is like a list, except it's immutable or mutable, so you cannot change it. So for each item in my tuple, print a tuple. And here you have for 1 and 1, or for 1, print 3, print 5, print. And when your tuple's out of objects, the script block stops, your for loop ends, and you're done. Now here we have a list of words. Hey ho, let's go for you Ramones fans. For each item in my list, print the item. For Val in my list of hey ho, let's go, print hey. Print ho, print let's go, we're done. Right? So you start to get the drift here of how powerful a for loop is. For each computer in my list of computer names, do this. For each update in my list of updates, perform this task. For each document in my list of documents, do this to it. Zip it or back it up, something like that. So for loops can be very powerful. It just doesn't have to be printed to the screen or iterated, which we'll learn, right? This is a dictionary. We'll talk about them more in lesson 4 and 5. It's a key value pair. So alpha is the key, 1 is the value. So when you call on the key, it'll print the value, right? And here we say for each key in my dictionary, if key is equal to beta, continue. In other words, don't do anything. Else, print the key and then call on the dictionary key, which gives you the value. So here we have for alpha in Greek, if alpha equals beta false, print alpha, Greek alpha 1. That's what we get. Beta continues. Continue will not do anything. It'll keep rolling through your iteration until, this is a prime example of if you didn't want beta to do anything to beta, but you wanted to pass alpha and gamma, this logic would make sense, and that's what we did. But for loops, right? Now, think of for loops. I mentioned this last week. If I were to tell you to do push-ups, and I said do 10 push-ups, for each push-up in my list of 10 push-ups, 1 push-up, 2 push-up, 3 push-up, 4 push-up, 5, 6, 7, 8, 9, 10, you're done. for loop, you have a group of something, or you may or may not know how many are in that group, but you're going to do it anyway, right? Your list, your object, your dictionary, something like that. Your string. Now, a while loop is used while an action is being done or not done, right? So if I were to tell you use a while loop, a good example back to push-ups, if I said do push-ups, while you have energy, you will continue to do push-ups. Stop at 30, 50, 60, 70, whenever you're tired. I didn't tell you stop at 10, right? I said do push-ups. So that's a big difference between the for and while loop. While a condition is met and while you have objects. Let's take a look at a while loop. Get rid of this. So while loops, though handy, I often don't use them. It's just my own personal scripting style. You'll develop one over time. A lot of times I know I have a list of objects that I have to deal with. So usually, I have lists. So for each item in my list, do this. It's very handy. For each user in my list of usernames, reset their password. Things like that. You can automate that stuff. Let's take a look at this. Counter equals 3. While counter is greater than 0, print counting down, counter minus 1. Counter equals counter minus 1. That's what this is saying. So it's the same as this. Counter equals counter minus 1. This is a long way. This is more Pythonic. Does the same thing. So let's talk this out, right? Counter equals 3. While 3 greater than print counting down 3. You get it? So now when I run this, oh no! I left this here to show you that that's a bad thing to do. And now I have an endless loop. This is the danger of while loops. An endless loop that never stops. And it's going to end up crashing your computer or filling up my memory or something. Close the program. And that was all done by design, believe it or not. So we'll discuss that after I show you the other while loop, right? As I have to fly through here really quick. That's 3. While loop. All kinds of fun stuff to cover. While and range and for are pretty awesome though. While loops are awesome too. Don't get me wrong, but there's just that danger, right, of an endless loop, which we saw. So this right here, if I were to save it, it'll perform the task until this condition is met. You'll see people put while true, and then they'll put a break down here. That's bad logic. That's literally lazy programming. Like, while something equals true, and then change the logic so it's no longer true, and then your loop will stop. If you just put while true, why even put while true? Just run what you need then. You don't need the while true statement. 90% of the time, you don't need a while true statement. But this counter right here, counting down 3, 2, 1, and I'll pick on you if you use a while true without like changing it, or if you use a break, I will make fun of you. But let's talk about this on why this never executes, right? Or ends. Counter equals 5. While counter greater than 0, print block never executes, print when this condition is false. Well, it'll never be false because 5 is always bigger than 0. So you just keep getting these printed to your screen nonstop. An endless loop. Bad logic, right? Incorrect, incomplete logic. Just if you talk it out, it makes sense, right? So here comes the breaks, right? While 1. Okay, well, while 1 is what? Let's go. 1 is what? 1, enter. 1 is 1. Is 1 equal to true? Man, I gotta spell it right. Is 1, like I said, it's not my normal setup. 1 equals true is true. So this is basically saying while true. While true, counter set to 0. Print execute at least once. If not 0, break. If not 0, break. If not true, break. What does that mean? Well, break will cause your script to exit. So even if your logic is faulty, it'll still end, right? What if I comment this out, save it and run it? Ah, look at that. Your if statement, it wants something. It wants something to do after the if statement. It needs a script block. All right, so we'll do this. We'll just print test. Ah, inconsistent indentation. So you notice that it indented it way back here. You need 2 tabs, save, F5. Inconsistent. What's so inconsistent about it? It's at 4 tabs, right? Let's see. Enter. 1, 2, 3, 4. There we go. Still inconsistent. Well, where's it broke at? Inconsistent indentation detected. Easy to fix, or mixed tabs or spaces. That may be a problem. So that's a tab. That's a pretty big tab, isn't it? That looks about right. There we go. So now we have our endless loop again. Trying to break it on my end. Might have broke it. Let's talk about this. While 1, while true, always true. Print executes at least once. If not true, well, guess what? It is true. So it's going to keep printing, test, execute at least once, test all the time. It's never going to break. That's why we impose the break. Of course, I broke it. It's filling up everything. Close it. These are important to show you too, because you're going to run into these. You're going to see me do a lot of errors throughout this course and exercises because you need to see them. And so when you create one on your own, it's not the first time that you see it and you're like, oh man, what is this? You know, I'm fine with showing you errors and mishaps. That's how you learn, right? And it's okay if you get red, and it's okay if your script doesn't work. You know, you can always go back and fix it and change your logic. But this joker, that's the reason why the break is there. Because now both of these only print once. Oh no, inconsistent again. Boop. So now this printed once, while true, print, counter is not true, print, test, break. And the break is what made it stop from being an endless loop, which is sloppy programming. So if you change this to while 1, or if you had a variable set to var1 equals true, and then right after print, you could do var1 equals false and remove that. Oh no, what happened? It all comes down to where I put my variable 1 false. Right? So take a look at this. Plus, I never called on it. I never put while var. So that was a bad one. That was my mistake. I broke that. But that's okay, because now you're going to see me redo it and fix it. Boop, 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 boop. And it's okay. You can use Task Manager to kill your stuff, or press a Control-Shift Escape to do that as well. So while loops, your logic has to be on point. You have to plan it out, pseudocode it, makes sense, right? So let's say var here. While var, I'll change this to var. Well, let's say while var is equal to true, because that's what it's set to. Var is equal to true. And here we're going to set it to false. So in reality, it should just print once. Exactly. See, that's how you control it with logic. You no longer are forcing a break. You're doing some print statements, and then your logic is, well, I changed var to false. You can have an if statement, else statement here. If this, keep going, else change var to false, then it'll break. So it could like execute 3 or 4 times and then break if it doesn't meet it anymore. You do all kinds of cool stuff. I just want to point that out because while loops get wild. Let's take a look at this. So we're going to touch on a couple advanced things here, but that's all right. Right, that's how you learn, and feel free to use these in the future. So here we have a list, 2 items, Zach and Liam. While names, while list, while my objects in my list, print names pop. Pop is a method of a class of the list class, and this is a list object, so it's basically a function of the list. Pop without an argument takes the last item, displays it, and then removes it from the list. So on the next iterations of the loop, while names will only have Zach, it'll pop that, and then names will be empty, and then it should end, right? Because there's no more items to print. That's exactly what we have. So while names, print names pop, Liam is going, print names, Zach is left. While names, print names pop, Zach, print the list, it's empty. And then the while loop exits. But we had to remove the items from the list with using pop. We'll talk more about that at a later date too. Let's see, this is a while loop. Let's check this out. Get rid of this one. Let's take a look at this code right here. So this is a results 101 processed passed. These are counters. We set them to 0. While results, in other words, while there's something in my list, add 1 to processed. So this counter will go up. Should be a 3, right? Because I have 3 items. So go through it 3 times. If result, continue. In other words, it'll pass if it's 0 or if it's 1. We'll see how this goes, right? But then at the end, while it breaks, we'll get our print statement. We'll see how it goes. So at the end of the day, we process 3 past 1. So what this is looking for, if true, continue. Because 1 is true, right? If true, continue. If 0, if false, pass +1. That's what we get right there. Then we're here with this 1 again. Continue. So that's why we get our 3 processed and 1 passed. Kind of bogus, but it's an example. It's from your book. I'm going to teach it. It's cool, right? So can you nest forward while loops? Yes. What's the best way? Well, think of if you wrote something and called it, got your header up here, play equals true, right? Or just say something easier, yes. And down here you could have while play is equal to yes. Print, welcome to the game. You are playing a game. Playing a game. Print. Do you like checkers? Checkers question mark. Let's change that to user input. Call it a user in equals input. We'll delete that. And we'll give them a little guidance. We'll say print yes or no. Get rid of that. Put this here. So we got user input yes or no. I could say if user in is equal to y, print I like checkers too. That's fine. And we just do else, but we'll do elif. Elif user in is equal to no. Print that is sad. I like checkers. Now we can get tricky here and say play down here. Say play equals input, ask them again. Would you like to play again? If this was a game, we get the gist of it, right? And here we tell them yes or no. Tell them what the enter yes or no. Now what would happen there? Let's do this. There. So in theory, play equals yes. While yes equals yes, print you're playing a game. User input. Do you like checkers? Yes or no? If yes, print this. If no, do this. Error print. Well, what's going to happen if I keep saying yes? So should be keep looping, right? We never change the value of play, so it'll just keep looping over and over and over and over, right? Let's run this. Save. I'll call it a loop test. Loop while test. Hit F5. Right here. Do you like checkers? So I'm right here. If I answer yes, it should continue to loop. Let's see. Yep, sure does. Oh, no. Would you like to play again? So I hit no. If n equals y, false. Else if n equals n, true. That is sad. I like checkers. Would you like to play again? That's where I'm at. And if I hit yes, it should prompt me again. Sure did, because I never changed the value of play. It's still yes. So while yes is yes, do you still like checkers? Now I'm going to hit no. And I'm going to type no, and now the loop breaks. So you can do some pretty cool logic with while loops, and placement of variables and reinstantiation. So that's a big word, just meaning change the value of an existing variable. That's it. Because you reinstantiated the value of play to be no instead of yes. Same variable name, different value, right? That's basically while loops, for loops, and ranges. We could put it to work by doing some pretty cool stuff. Let's see what got up my sleeve here. Let's do the this one's fun. If I remember. This is roll the dice and stuff. This is all your group exercises. Well, now you got those, right? But in reality, let's talk about pseudocode. So the more complex your scripts get, the more you need to write a quick story about your code. A make-believe story doesn't have to be real code. It just has to be things you need to do. So if my boss told me, hey, I have this list of computers, I need you to check if they're on. Okay, so for each item, for each computer in my list of computers, ping it. If it comes back true, say computer name true, else computer name off. So I know if it's on or off. That's simple, right? So if I had a literally just call computers and equal and create a list, open, close, give it, that's what my first object. My second object is comp2. It's going to be more complex than this, right? So here's my list. And I'll say for each computer in computers, perform this task. That's pseudocode. Now, what I usually do is the things that I can't code become my comments only while I build my code. So now that I know each of these is a computer, and for each computer, my computers do something, I could comment this out, hit end, and start to pull in my things I need, like I'll need import OS, import sys. Perhaps those modules will help me. And then I can start typing the rest of my code for each item, for each computer. You use the computer name to ping, use DNS, use the full name and ping it, see if it comes back, and it should send you a true or false or 1 or 0. And then you could complete your logic that way. But writing your story, you could use this for so many things. Like right now, you could perform this task. What task do you want to perform on a computer? Pull a serial number, pull the OS, make model of the machine. Same type of logic. You could do those all for that one computer. But you can build some pretty cool tools. And throughout this class, we're going to start getting more tricky. I'm going to start bringing things to light, like the OS module, the sys module, not just to use Python to have fun with strings and build games and communicate, build it to automate tasks on a computer, right? And it's basically easy, awesome language for machine learning, neural networks, and AI too. It's the foundation. It's a foundation language for that. But it all starts with for loops. All starts with if-else statements. And it all starts with knowing how to save a file and how to name them right. So you already learned a lot in the past 2.5 lessons. This is just some more tools you can put in your toolbox. But do me a favor, fill out that discussion board. If I don't get a lot of interest, I won't do it. If let me go back to that announcement. It's just me, and if you guys have questions, go to the discussion board. I already have a couple people. Go in there, add a thread, yes or no, what day would be best for you. On Friday, I'll go through them all, and I'll annotate everyone's days, and I'll determine the best day based off of your data, and I'll put out something in a week or so. All your grades will be done by tomorrow midnight, so all your grades will be updated by tomorrow midnight. Keep that in mind as well. If you haven't completed anything, turn it in ASAP. Late work, if you have late work, email me. We'll talk about it. Other than that, have a great evening. And if you have any questions, feel free to email me. And I will talk to everybody soon. So have a good night. Take care.